In this problem, we're asked to find a rectangle of area 9, which has the smallest perimeter. So we know that the area needs to be 9, and we're working with a rectangle, and we want to find the smallest perimeter. So placing down all our facts, we know that 9, well, let's draw a picture first, I guess. So we have a rectangle, and it's going to have some height x and some width y, and the area has to be 9, and area of a rectangle is x times y. So this is a constraint, right? This is fixed. We're not able to change this, but we want to find the smallest perimeter, so we want to minimize perimeter, which is, well, the perimeter would be, so let's call it P of xy, and it would be 2x plus 2y. That's our perimeter. And we want to minimize this. Well, as in every other problem we've done so far, right? This has too many variables, so we get to use our constraint to reduce the variables down. So since 9 is equal to xy, this tells us that y is equal to 9 over x. And so the new problem to solve would be to minimize the function p of x, which, taking this for y and putting it and replacing it right here, right? So this would be equal to p of x comma 9 over x, which would be 2x plus 18 over x. So this is the function we want to minimize. Do we have all our constraints? Well, another constraint would be that for this to have actually 9 area, neither x nor y can be 0. So x has to be bigger than 0, y has to be bigger than 0. This right off the bat says we have no endpoints, so all our minimum will happen interior. So solving this problem, we need to know when is 0 equal to p prime, which is 2 minus 18 over x squared, which means that bringing this over to the other side, 2 is equal to 18 over x squared, or dividing by 2 and multiplying by x squared gives us that x squared has to be equal to 9, or x is equal to plus or minus 3. Now we can throw out the negative 3 since we know that x is positive, so this goes out of the way, and we just have our one critical value is 3. Now we need to confirm that this will give us the smallest perimeter, so we have to use the second derivative test. And so p double prime of x is equal to, so this is x to the negative 2, so we just write it's the derivative with respect to x of 2 minus 18 x to the minus 2. So the derivative of 2 is 0. This 2 comes down, gives us a positive 36. So this is equal to 36 x cubed. And so p double prime of 3 is equal to 36 times 3 squared, 3 cubed, which is 27, which is positive. which means, so since that's positive, that means P of 3 is a min. And we're asked to find the rectangle of area 9, which has the smallest perimeter. So we need to find what x and y is. We know x is 3. And from this equation here, y is 9 over x. So if x is 3, then y is equal to 9 over 3, which is also 3. So we see that it's actually a square that will minimize the perimeter. And our answer is that a square with sides 3 will minimize the perimeter.